students, Mr. Clausen here. Just wanted to go through the follow-up to the lab activity you just did with PhET. So if you're seeing this video, it means hopefully that you have a document that looks like this in your email. And just like it says, this sheet has your answers from the quiz. Your answers are highlighted in gray. And you might need to make some revisions. So let's go ahead and take a look at it. You're going to put this in your notebook where it says, for an essential question, are what are the parts of an atom? So let's get started here with the diagram. Let's just make sure you got the proper parts labeled, and you might need to add this anyways. Let's go ahead and label the three parts that are inside the atom. They are the neutron, the proton, and the electron. All right, and then each one of these has a symbol that's a little bit easier to remember. So the neutron is an N with a little 0 up by it. The proton, being that it's positive, has a little positive sign. And the electron is the letter E with a little negative. Let's go back up now and start reading. Center of the atom is called the nucleus, and the nucleus contains the positive protons and neutrons, which are neutral. So if you didn't have that down, this is where you would go ahead and make the revision as possible. Okay. Scroll back down here. Because those are in the center of it, we have something that we call the mass number. And the mass number is the number of protons plus the number of neutrons. And the reason we don't include the electrons is like it says right here. Electrons are just very small considering the size of a proton or a neutron. They are about 18,000 times more massive than the electron. The way I like the story I tell for this is imagine you got yourself a little elephant. Okay, maybe not a little elephant. You got a big elephant. For whatever reason, your job is to weigh elephants. Right? So there he is shooting his water at you. And his little tail. So you get the elephant out, you put him on a little elephant weighing scale, and you'd read off a number over here on the side. But if a little fly flew and landed on the elephant's back, that elephant technically would weigh a little bit more, but you're not going to concern yourself with the mass of the single fly adding a little bit of weight to it. Because the elephant is just so much more massive, that little bit of extra mass due to that fly being there really isn't going to affect it. And that's really what's going on here with the protons and the neutrons when it comes to the mass number. So the mass number is just how much matter or how massive the nucleus is. And so we just concern ourselves with the two things that matter there, the protons and the neutrons. Okay. Now there's another number that's important. This one's called the atomic number. It is simply just the number of protons. Okay, so just the number of the positive protons. So the atomic number is equal to number of, and we can write that in here, number of the protons. And it tells us the name of the element. So this is an important thing to note. So for example, hydrogen, all hydrogen atoms have one proton. If you have one proton, you're hydrogen. If you have two protons, you're no longer hydrogen. You've turned yourself into helium. Okay, and it continues like this. I think the next one is lithium. Lithium has 3 protons. And that's just how it goes. So by changing the number of protons, you change which element it is. Okay. Then we get this to the last one we just want to talk about here. It's called the electron, and they are negative and they orbit around the outside of the atom, which is good for now. All right, let's go down to this next part, which is kind of a thing you wanted to figure out from the activity. And it says that not all atoms are exactly identical. Now, most atoms are neutral, like it does say there. And what we mean by this is that the number of protons equals the number of electrons, which makes sense. If a proton is positive and an electron is negative, in order for them to add up to 0, those two numbers would have to be equal to each other, right? So if I had 3 positives, I'd have to have 3 negatives. And so that's how it works out in most cases. Now, notice I said most case. An ion, on the other hand, is an atom that has a charge. And to do this, what it means is it has gained or lost an electron. Right, now you notice that we said it's gaining or losing of an electron. That's the key important part. And the reason it's the electron and not the proton is it's the electrons that are on the outside of the atom and are able to be removed. If you remove a proton from the atom, that atom is no longer that element and things have changed. An ion is still going to act a lot like what that element was. It's just it's now going to have a charge and be able to bond a little bit differently. To find the charge of the atom, all you have to do is take a look at how many protons you are. So if you have more protons, they're positive, you're going to have a positive ion. Positive ions are called cations, by the way. If you end up looking at the number of protons and electrons and you find out that you have more electrons, well then what you're going to have is a negative ion, and those are called anions. All right. The last one here is this idea called an isotope. Some atoms are a little bit heavier and a little bit lighter, and we call them isotopes. The biggest way you can see this is if you ever look at the periodic table, you'll notice that if you look there, I'm trying to do this from memory here, carbon, it'll say 6 on top, and then down below it never says a nice round number. It's always some weird thing. So like carbon, I think is like 12.001. Well, that right there is the mass number, which we talked about before. It's supposed to be the number of protons plus the number of neutrons. And my question is, how do you have 0.001 of a neutron or 0.001 of a proton? And you can't. And what this is this is the average mass number of that element. So some atoms, due to just reasons that it's the way it is in nature, they'll have an extra neutron here or there. And so if it's a little bit heavier or a little bit lighter, that's what we call an isotope. So an isotope is something that has the same number of protons, but a different number of neutrons. All right, so there it is. That's the follow-up to the lab. So hopefully that helped you out, and if not,